Hi everybody. So this is second lecture on electric charges and FETs. So let me write it first. In my previous lecture, I can recall that I concluded while uh, I was discussing the properties of charges. And we already have learned two properties, the polarity of charges and second we have learned quantization. Quantization of charges. Now today uh, I'll discuss the third property of charge, and that is additive nature of charge. Additive nature of charges are a scalar quantity. So as it is scalar quantity, it can be added or subtracted algebraically. So charges are added algebraically. For example, if you have 4-5 charges, like one of magnitude minus 4 coulomb, other is of magnitude minus 3 coulomb, next is of magnitude plus 2 coulomb, next is plus 1 coulomb. So the whole net charge on the system on which these point charges are there, the whole charge, the total charge, net charge, is equal to algebraic sum of all these charges. Means minus 4, minus 3, plus 2, plus 1, or this much coulomb. So it comes equal to 7 and 3. So it comes equal to 4, minus 4 coulomb. So this is net charge in this very example. Now let me take another example. Suppose you have a collection of some protons and some electrons on a body. Let me take few examples, like 2 protons, 5 electrons, then 4 protons, 3 protons, and then 9 electrons. Then what is the net charge on the system? Net charge will be equal to I should say net charge on system. Net charge, therefore net charge of the system, is it right? On the system is equal to, and for proton I'll be writing plus E, and for electron I'll be writing minus E. So we have net charge equal to plus 2E minus 5A plus 4e plus 3e and then minus 9e. So total we have 7 plus 2, 9a plus 9a minus 9a and minus 5a. So net charge comes equal to minus 5a. So this is the additive property of charges. Now next property is conservation of charges. Conservation of charges. Conservation means charge cannot be created, charge cannot be destroyed. So we can only create or destroy net charge on some system. Sorry, I wanted to say that uh, we cannot not create charge. We cannot destroy charge. On an isolated system. On an isolated system. Let me take some example to explain this. First example is while pair production. When two gamma ray which are in motion, and when its energy due to motion is converted into rest mass of some particle, then we have one proton and one electron. So previously the gamma ray has no charge. It is an electromagnetic radiation, so it is chargeless. And finally also, when we have one proton and one electron, so plus E and minus E, then again we have zero charge. So in this way we can notice that initial charge is equal to final charge. Let me write it. When two gamma ray utilizes its kinetic energy and produce proton and electron. In this case, initial charge on the system is equal to 0. And finally also it has charge 1 plus E minus E equal to 0. So this is a very good example and it comes in exams also. So just remember it, pair production. Now next one is annihilation of matter. annihilation of matter. When one proton and one electron collide with each other, collide with each other, two gamma rays are produced. So, charge initially is equal to plus A minus A equals 0, and finally the charge on gamma rays is equal to 0. So next example, let us learn 2-4 examples so that when it can clear your concept. Now in nuclear reactions, the net charge remains conserved. So let us take some examples. When uranium 92 is bombarded with neutron, I should say 235, uranium 235 is bombarded with slow moving neutron, then it can be converted into daughter nuclei in so many ways, and such that the net charge, sum total of net charge after reaction, nuclear reaction, remains same. Like one way it is disintegrated into barium and krypton. Now barium has its atomic number 56 and krypton has atomic number 36, and emission of 2 or 3 neutrons also is there. So net charges before the before reaction, net charge before reaction is equal to 92, and after again it is equal to 56 plus 36 is equal to 92. Now so many ways in which uranium can disintegrate. Let me take one more example. When it is disintegrated into indium and yttrium, so indium has its atomic number 53 and yttrium has its atomic number 39. So here also we can see that charges before nuclear reaction is equal to 92, and after reaction it is equal to 53 plus 39 and it equals to 92. So charges remains conserved. So many other examples also are there. We can take some more examples, like one we have taken pair production, other is annihilation, third is okay nuclear reaction. Yes. Take example of NaCl. It is chargeless. Now, when it ionizes, in water, then NaCl becomes Na plus and plus Cl minus. So net charge after ionization is equal to plus 1 minus 1 and it is equal to 0. So charge remains conserved. So many examples are there, and in each and every example it is obeyed invariably. So charges remains conserved. Now when charges remains conserved, then how we can charge somebody? So it can be explained that charge cannot be created, it cannot be destroyed even. We can create only some net charge. We can create some net charge on a body. So how body can be charged? Now next topic is this, charging of body, and what is the principle behind charging of so there is electronic theory of charging. Electronic theory of So let me explain the construction of an atom and how the charges are arranged over there. So in an atom, all the positive charges are there in nucleus, all the positive charges. And electrons revolve around the nucleus in different cells. Here, the positively charged central portion, that is called nucleus. And in outer subcells, different cells, electron revolve. Now the size of this nucleus is very small. Its diameter is of the order of 10 to the power minus 15 meter, means 1 femtometer. Whereas the diameter of an atom is of the order of 10 power minus 10 meter. So a big difference in between the size of nucleus and size of atom. Just imagine if you magnify an atom, so the size of nucleus will be, if it is as per the pinhead, size will be similar to the dimension of a pinhead, then the size of atom will be the dimension of a big hole. So how small the nucleus of an atom is, you can imagine in this way. So if we enlarge the enlarge an atom, then we find that if the size of nucleus is comparative to that of a pinhead, then the size of atom will be comparative to the size of a big hole. Okay. Then electrons remain attracted by this protons by being in various cells. They are very strongly attracted. But when we proceed towards outer cells, the distance between these positive charges and negative charges is increased. Distance is increased, and and the force of attraction, nuclear, I should say electric force. Electric force is inversely proportional to square of distance. So as we proceed towards outer subcells, and due to increase in denominator, the force reduces. So force of attraction on these outer electrons is very little. So due to inverse proportionality, of force from distance square, the force on outer subcell the force on outer subcell electrons is small. So in many materials, these are free to live. atoms. Now, when atoms combine, they form molecules, and finally molecules combine to form extended objects. So initially atoms or objects, atoms or atoms or objects are neutral as it has same number of protons and neutrons, protons and electrons. Showing by one model, if we have two protons, then we have two electrons also. And when this atom is forming some extended object, and which is neutral one, number of protons, number of positive charges are equal to number of negative charges, and we have two extended objects. It has same number of positive charges as it has number of negative charges. Now what happens when we rub these two objects? So in the way in which a towel wipes the dust from your faces while rubbing, uh, electrons from one object may get transferred to other object, and it is due to that electrons are very loosely bound in some materials. So when we rub these two materials, electrons from some electrons, not all, some electrons may transfer from one object to another one. Suppose 3 electrons get transferred. So here it becomes 1, 2, 3, 4, 5, 6 proton positive charge. 6, 5, 6, and 3 get transferred. It goes to other objects. So you can see that first become deficient in negative charges. It becomes deficient in the first is deficient in negative charge. So it becomes positively charged. Positively and the other body becomes rich in negative charges. So it is called negatively charged body. The two body get charged due to friction. The two charge due to friction. Methods of charging. Yes. Methods of. Now the first method, this is charging due to friction. Second method, charging due to induction. So what happens when you brought a charged body near an uncharged body? What happens? Suppose we have one positively charged body and we brought that positively charged body near to an uncharged body which is kept over an insulated stand. So when it is brought near the uncharged body, so what happens that all the unlike charges will be attracted near this closure surface. Unlike charges will be attracted and like charges will be repelled to farther surface. We can see that there is a redistribution of charge. The charges are redistributed over here, and this redistribution is termed as induction of charges. So what is induction of charges? The redistribution of charges on a body due to presence of a nearby charged body. Is called induction. It's called induction. Now, how can you charge two uncharged spheres? Charging of two uncharged spheres. The two uncharged spheres withstand with insulating stands. are kept in touch side by side. Are kept in touch side by side. And charge body is brought close to any one of the sphere. Suppose a negatively charged body I have brought here, then all the positive charges from this uncharged body will be shifted, not all, few, will be shifted uh, near to a closer surface. And I'll explain why not all charges. I'll explain. And all the like charges will be repelled on the farther surface. And after that, we physically separate the two surfaces. Here, one surface gets positively charged and the other negatively charged. Now, I told that not all, few charges get shifted, and there is the reason. Suppose all the charges start gathering uh, towards opposite directions, and some field is created, and due to that field, the other charges will be repelled to opposite sides. So not all, but a fraction of charge get collected on the near surface, fraction of opposite charge get collected on near surface, and a similar amount of charge get collected on the opposite surface. This is charging of two uncharged spheres. Now, next topic is charging of a single sphere. So, we brought any charged surface in the similar fashion. Let this time I am taking positively charged body near to this uncharged body. Then all, not all, a fraction of negative charges will be attracted towards this positive charge, and a fraction of positive charge will be repelled to the opposite direction, opposite surface. Now when you connect this to earth, and you will see that these are called bound charges. These are bound charges. They will not live, but when you connect this to earth, these free charges will be vanished. But each time only electrons will be transferred, will be so this time as it is about 1840 times less heavier, or I should say lighter, lighter than protons. So in so many examples we have seen while curdling, as also you have seen that the lighter butter get sifted towards periphery, and the heavier curd, other heavier material remains seated on the bottom. That happens here also. Protons are very heavy, so they cannot shift from one body to another. So every time these are the electrons, we shift which way they have to shift it. So in this very case, electron goes from Earth to electrons go from Earth to that sphere. In this case, transfer from Earth to the sphere. What happens if we had taken a negatively charged body near to this sphere? This time, positive charges, a fraction of positive charges would be attracted towards closure surface, and at further end there will be negative charges which were shifted. So now these these positive charges are here bound charges. Bound, they will not move. Bound by these electrons. Bound by they will not move. Now, when we earth the sphere, the negative charges of the sphere get shifted to the earth. So this is charging by induction, and what we seen that by charging in this method we have to take always charge of opposite nature. Means if you have to charge any sphere, any object by, suppose you have to charge by positive charges. So for that, for induction, we have to take the charged body which is of opposite polarity. We have to take negatively charged body. So charging by induction, for charging by induction, we have to take a charged body of opposite polarity. Means okay. Now next topic is charging by conduction. Charging by. So these are the three ways by which we charge any body: charging by friction, charging by induction, and the last one is charging by conduction. So when an uncharged body is connected with a conducting wire to a charged body, the charges are shared to hold the body proportionally. Proportional to the size and nature of material. Nature of material of the body. Okay. So here what we saw, that here we have, for charging we have to take charges of same nature. Here we have to take charges of same, and also here the same charge is shared, means magnitude of charge is reduced. Charge is reduced. But in induction, there was no reduction of magnitude of charge. Rather, the same magnitude of charge but of opposite nature get developed. So these are the differences of induction and conduction. So method of charging, before that we did electronic theory of charging. Okay. Method of charging now next. Classification of matter. Classification of matter on the basis of conduction. Basis of three kinds. First one is conductor. Second one is insulator. And third one is semiconductor. Now let me describe the conductor, the first one, conductor. These are the substances which conduct or transfer the charges through it here, the charges cannot be held. Charges cannot be. As the charges flow, so it cannot held the charges. So all charges flows through conductor. So it cannot be charged by the three methods what we have discussed before, friction, induction or conduction, until unless it is not kept on an insulating base. So conductors cannot be charged. Now second substance is insulator. Insulators generally have not mobile charges or free charges. In insulators, in some materials, the outermost cell electrons are held very strongly. So they are not freed from their periphery. They do not leave their atom. So insulators are deficient in mobile charges or free charges. So insulators do not conduct charges. When they do not conduct, so they just hold the charges. They are charged. Inductors hold the charges, so they get charged. Inductors hold the charges, do not conduct, and hold the charges. So out of conductor and insulator, insulators are the objects which can be charged by these three processes, by friction, induction or conduction. So only insulators can be charged. And then some examples I would like to give. All the materials that do not conduct electricity, like in our houses we have plastic or switchboards, plastic, wood, ebonite, all these are insulators. There are so many other examples you will find and you will just learn. And next one is semiconductor, about which we will learn in some other chapter. Okay. So let us come on the next topic. Yes, one more thing is remain. How we can measure the charges? Charge is measured. Charges are measured with the help of device called electroscope. There are many kinds of electroscope, but I would like to take two more relevant one. One is gold leaf electroscope, and other is Peace ball electroscope. a small description of gold leaf electroscope I am giving you by drawing a schematic diagram. So for a gold leaf electroscope, we take a glass jar and which is evaporated, and in glass jar we fix a rod, a conducting rod, and which hangs gold leaf, which is very light gold leaf at the lower end. Gold leaf we take in this very device because gold leaf can be uh, uh, bitted to a very thin, a very fine stripe. So we generally take in electroscope a gold leaf, and at the upper end there is a disc. Now suppose we have to test whether an object is charged or not. We test the object with that, this part. So if it is charged, suppose it is charged 1, the charges flow up to this gold leaf, and due to charges of opposite nature, this gold leaf opens, and the amount by which the gold leaf opens, this gives the magnitude of charge. So this is how we measure the amount of charge on any body. Other one is peat ball electroscope. In a peat ball electroscope, a peat ball is suspended by a cotton thread. Now, when a charged body is brought near to it, it is get deflected. And then it tells that the body is charged one. And if it is not got deflected, it means the body is uncharged one. So this is description of electroscope. There are so many kind of electroscope, but these two are very general one. Generally we use even in laboratories also. We have such this peat ball kind of electroscope can be made and used anywhere. So you can also make your this peat ball electroscope using thermocol. If you take a small sphere of thermocol and hang it with the help of cotton thread, then it will act as a electroscope. Okay, thank you. In the next lecture we will be discussing about electric forces. Bye.